To start on this problem, for part A, the one thing to remember is that torque equals R cross F. So what is the net torque then? We just subtract the two sources, one that's going counterclockwise and the other one that's going clockwise. The counterclockwise one is a force of 4 mgh, and it is going at a distance L away from the axis of rotation. We then subtract another mgl going from the opposite direction. This leaves us with a net torque of 3 mgl. For part B, it is good to remember that torque equals I alpha. However, we must first determine what the moment of inertia is for this shape. Since we're just considering point masses, we can just use the formula that the inertia is just the sum of the ml squares. So we then have 4ml squared plus ml squared, each on the different sides, one with the bug and one without. We have determined that the moment of inertia is 5ml squared. We can then write alpha equals tau equals sum of the torques over the moment of inertia. So 3mgl over 5ml squared should leave us with 3g over 5l. Now on to part C. For this part, it is probably best to use conservation of energy. So we can say that the kinetic energy at the bottom is equal to change in the potential energy from the top. So 1/2 I omega squared will be the kinetic energy. The potential energy will be slightly different because one of the blocks went up. That will actually be the top mass is actually negative mgl, while the bottom mass is going to be 4 mgl. This is the change in height, as you can see. Simplifying, omega squared equals 6g over 5l. Therefore, omega equals the square root of that, or square root of 6g over 5l. Now that we have the answer to part C, part D is quite easy. For if you remember, angular momentum equals I omega. So we just plug in our values for omega and I, and we arrive at the desired answer. Part E involves a discussion on centripetal force. So we know that centripetal force equals v squared over r, which, through a little substitution, should give us omega squared r. Oh, sorry, I meant to add that m as well. So the centripetal force equals mv squared over r, which equals m omega squared r. So substituting our values we get, so we substitute the mass as 3m, and omega squared, as we saw above, was 6g over 5l, multiplies the radius l, and that should give us 18/5 mg. Now, that force must be directed inwards. So now we can just use summation of forces, and we can figure out what the force that the sphere must exert on the bug. So that 18/5 mg equals the force of the sphere, which should be going upwards, minus 3 mg, because that's the gravity pulling it downwards. So we find that the force of the sphere must equal 33/5 mg. And of course, it must be directed upwards so as to prevent the centripetal force required to keep it moving in a circle. Thank you for listening to my explanation of problem number 511 in the chapter for angular momentum. This is Ashwin, and thank you.